Hello, grade 10s. How are you today? This is Patrick Kamala, tutor and educator for mathematics and physics. Grades 10 to 12. Today we are having our math lesson for this holiday about two functions. I hope you're going to enjoy it. Let us dive into it and continue with it. Okay. All right. So this is a continuation. We're doing question 8 now. It says that given the sketch of the straight line g of x, this one here, you can see that equals to mx plus c, and the parabola f of x equals to ax squared plus b, with the points a, this is point a, and the d, 1 is to 0, okay, this one here, and then as the x-intercept of the function f, and the a is also, this a also x-intercept of the straight line graph, then b, 0 is to 2 is the y-intercept of the straight line, and then e, and the e is y-intercept of the parabola. So C is the point where the two graphs intersect. They intersect at point C and the point A actually here. And that's what they want us to get now. They said that determine the values of M, C, A, and B. M, C, A, and B. So to get our M, C, A, and B, we're going to find out now the M is the gradient, and then the C is the y-intercept. So actually our C is this 2. Hello, are we together? Our C is what? Our C is 2 because that's the y-intercept for the straight line. Okay, so in this case, our C is 2. Our C is 2. You're doing this question 8. You're welcome. Okay, they said must find MC, A, and B. Okay, so this is a straight line here, guys. Note that whenever you've got a line equation y equals to mx plus c, okay, mx plus c, the m stands for the gradient. What about the c? C stands for the y-intercept. Are we together? Now, what do you mean by y-intercept? We mean the point where the line crosses the y-axis. So our line here is crossing at 2 here. Mean that our c is going to be 2. So our c equals to 2. Our c equals to 2. So to get our m, I'm going to consider the 2 points. That's point B and A to get my gradient. M stands for gradient. So the point A, we have -1 is to 0. Okay. And then the point B, we have what? We have 0 is to 2. So we can find our gradient m here. So our m is going to be y2 minus y1, okay, over what? Over x2 minus x1. So the moment you say line BA or AB, this is y2 here. It's going to be 2 minus 0 divided by 0 minus minus 1. 0 minus minus 1, which gives us actually 2. So therefore our m is 2. And so our line equation becomes what? Y equals to 2x plus 2. That is because they said calculate m, c, a, and b. So far we have the m and the c. Now we need to find about the parabola. That is with the m and the what? That is with the a, this a and the b. Now the parabola, as you can see, it is passing through point E and then point A and D. Okay. So we need to find the values of A and B. We need to find what? Values of A and B. So we are going to say that here our parabola y equals to A x squared plus b. Okay. Now at this point A, our at point E, our x is 0, isn't it? So mean that we can say that our y at point E equals to A, x is 0, it's gonna be 0 here, squared, then plus what? Plus b. I'm trying to get this b first now. So what is my y at E? The y at E is 5, so I'm gonna say here it's gonna be a 5. Okay, so this is 5 here. All right, so if you take what is 0 squared, guys, 0 squared is what? 0 squared is 0, right? Then 0 times a, we get 0. So meaning our b equals to 5. Our b equals to 5. Ne? Now I need to find my a. So to get this a, I'm going to use either this point a or point D. So I see that at point A, I have the coordinate, which is what? Negative 1 is to 0. I'm going to use again y equals to a, x squared plus b, ax squared plus b, a, x squared plus b. Now I know the b is 5, right? The b is positive 5 here. Now to get my a, I choose this point here, which is negative 1 is to 0. Ne? So I'm going to say 0 equals to a, then negative 1 bracket squared plus 5. Ne? Now the 5 becomes a negative 5 this side. Ne? Okay. And then the a, now the negative 1 squared gives us positive 1 times a giving us a. Therefore, our a is negative 5. So our a is going to be negative 5. And then our b is positive 5. Okay. Guys, are we together or somebody has a question? Are we together, guys? Should we continue? The question was saying calculate the values of a, b, c, and m. So our m is 2. Our c is also 2. Our a is negative 5. And our b is positive 5. Should we proceed or do you have a question? Shekaina, are we together? Are we together, Lufuno? Lufuno, are we together? Okay, let us continue. Let us continue here. Next question. They say that after getting the values for the function, we can now put them there. Okay. We know that our line, the straight line we have, it is what now? It is y equals to 2x plus 2. Y equals to what? Equals to 2x plus 2. What about the parabola? It is also y equals to our a. We saw it's negative. We're going to be negative 5 x squared. Our b is plus, then we say plus 5 here. Plus 5, okay? Let's what they want next now here. What do they want? Let's check it out. They said the coordinates of C. Now our C, this point C is where the two lines meet, where the two functions the two functions meet. So we must equate the two functions, to get our point C. So we're saying that at C, that's where the two functions meet, The two functions meet at C. So at point C, our f equals to g of x, So, but our f is the parabola, so I'm going to say negative 5x squared, okay? Negative 5x squared, and then plus the 5, okay? Plus 5 equals to 2x, then plus 2. Okay, so here I'm going to collect like terms, I'm going to say 0 equals to 5x squared, because now it was a negative, then plus 2x, okay? And then because I have a 2 and a 5 that side, the 5 becomes what? Becomes negative. So I'm going to say here, what is 2 minus 5, guys? You get minus what? Minus 3. So actually I'm going to solve. I'm going to solve what? I'm going to solve this point. This equation, this is 2x squared. That's a 5x squared, sorry. 5x squared. Let's check it out. This is 5x squared. And then plus 3, rather plus 2x minus 3 equals to 0. Let us do the cross method here. We can say 5 times 1, and then negative 3 times 1 here. Let us cross and see. Now if you cross and say 5 times 1, that is 5, okay? Then plus 1 times negative 3, that's negative 3. So when we add negative 3 plus 5, you see we get a 2, né? Which 2 is the middle term. You can see there's a 2 here, né? Which means to get our correct answer, we're going to say it's going to be 5x, okay? 5x minus 3 into x plus 1 into x plus what? X plus 1 equals to 0. So the moment we get here, we're going to say either our 5x minus 3 equals to 0, giving us x equals to 3 over 5, okay? Or our x plus 1 equals to 0, giving us x equals to negative 1. Eh? Now, if you check what we have with these two functions, already the negative 1, we see it here. That's where they meet here. This negative 1 here. This one, negative 1 here. So this must be done with the positive 3 over 5. No? So that's our x for the point C. But because we're looking for the coordinates, also need to find the y. No? So to find the y at C, I use this straight line here. I'm going to say that y at C equals to 2. I know the x now. No? It is 3 over 5. Okay. Then plus 2. Anybody with the calculator, chance do you get here? Anybody with the calculator? What's going to be the y at C? What is our y at C here? Anybody with a calculator, please check. What do you get here? Hello, hello. Anybody with a calc? That is 6 over 5 plus 2. 6 over 5 plus what? Plus 2. Now here I get 16 over 5. Ne? I get what? 16 over 5. So that's our y there. So the coordinates for C, which they wanted here, we're going to have it as C is what? It is 3 over 5 is to 16 over 5. Okay, guys, are we together? Shekaina, are we together? Lulama, we're together, ne? Lulama, are we together? So those are the coordinates for C. Now, what's the length of EB? Now, our EB gets from E up to B here. Now, if you look at our EB, it is a vertical line, okay? So being a vertical line here, what does it mean? We're going to say y at E minus y at B. I repeat, if you want to find the vertical distance, like in this case EB, okay, you subtract the y at E minus y at B. So our length of EB here, the length of EB, this one here, is EB, okay? You're going to say our EB equals the y on top, which means y at E minus what? Minus y at B. So the y at E, we have what? We have the 5, ne? Okay. What about y at B? We have the 2, which gives us 3. Which gives us what? 3 here. Okay, that's what we have now. That's what we have now. Next here, they said that we should find out what? Let's check it. Give the axis of symmetry for the function of f. Now, in this case, our axis of symmetry for this function is the y-axis, because this y-axis is dividing the function into two equal portions. Okay, so this y-axis, we call it the line x equals to 0. So here, our answer is what? Our answer is x equals to 0. X equals to 0. That's our answer here. X equals to 0. And then they say determine the equation of h of x, the straight line that is perpendicular to g of x and passing through the point D. I repeat, determine the equation of h of x, the straight line that is perpendicular to g of x and passes through the point D. Let's find out. Now, the point D is this one here. This is our g of x here. So one line which is perpendicular to that. Okay. So let's try to draw a line here from point D. But let me first get some space here. Get some space here. Okay, so now if the lines are perpendicular, what is to do with their product, with their gradients? What do we know about that? What do we know about such lines which are perpendicular? What is come again? To give us negative what? Yes, so thank you. So now if this is our line we're talking about here, it's passing through the point D, like you can see it here. But then they say it must be what? Perpendicular to this one here, to the first line. So meaning that we're going to have our 90 degrees somewhere here altogether. So now I'm gonna say that this one is our M1, okay? This is M1 for the one which we had here. This is our M here, our M1. Now our M1 from the given equation here is gonna be equals to 2. So to get my M2 here, M2 for this line which is in blue, I'm gonna use what? The fact that these lines are perpendicular. We know that when the lines are perpendicular, you multiply M1, okay, times M2 to get negative what? Negative 1, okay? So our M1, we see it is 2. Then our M2 is what we're looking for, okay, equals negative 1. So our M2 equals negative 1 divided by 2. Now, after getting the gradient for any line, and you have one extra point D here, then you can find the equation. Now, our point D, we have it as what? 1:0. So if I'm going to use y equals to mx plus c, now the m is what you see as negative half. I'm going to say y equals negative 1/2 x plus c. So to get this c now, I can use the coordinates at D, which is 1:0. So my y is the 0, and my x is 1, okay? Then plus c here. Now the negative 1/2 becomes positive, giving us our c equals to 1/2. Okay, our c equals to 1/2. So meaning that the equation which they call the h of x, our h of x, okay, our h of x, it is given by negative 1/2 x, then plus 1/2 plus 1/2 h of x together with the parabola and then the other straight line, one at a time. Okay, so don't forget that here my h of x, our h of x equals to negative 1/2, okay, x, then plus what? Plus 1/2. So if I'm going to intersect the other line, I'm going to equate this part, this one, equals to this one here for the straight line, okay? Then I'm going to solve for my x. So I'm going to say that this one is going to be 2x, okay, 2x plus 2 equals to negative 1/2 x plus 1/2. So this one becomes positive. Now 2x plus 1/2 x equals to 1/2 minus 2. So here, the 2 plus a half gives me 2,5. What about a half minus 2? Negative 1,5. So divided by 2,5, divided by 2,5. Anybody with the calculations that you get here? Which answer do you get here? Anybody with the calculator? Which answer do you get, guys? Come on, come on. Yeah, I get 3 over 5, ne? Negative 3 over 5. So to get my y, I come back to the first function here. I'm going to put this, I'm going to say equals to 2 into negative 3 over 5, then plus 2. So with my calculator here, I get my answer as 4 over 5. So y is 4 over 5 here. So therefore, this line, which is h of x, is meeting the straight line at this point here, which is called negative 3 over 5, negative 3 over 5 is to 4 over 5. Ne? That's our first point where this one meet, the lines meet. Now, meeting the parabola here, I'm going to equate this function to this other one now. Check it out. I'm going to equate the h of x to the parabolic function. Okay. So here, my parabola is this one here, and this is my h of x. Ne? So I'm going to say that my h of x, okay, equals the parabola, which is f of x. Ne? So I'm going to say negative 1 over 2x, then plus 1 over 2 equals to negative 5x squared, and then plus 5. Ne? Okay. Now the negative 5 becomes positive, the positive 5x squared now, okay, and then minus 1 over 2x, okay. Now this 5 becomes a negative, so what's a half minus 5? I get negative 4,5, ne? Equals to 0. So what do I do here? To remove my fraction, I can multiply by 2. So 2 times 5, I get 10x squared here. Here the 2 is going to cancel. Now 2 times 4,5, I'm going to get 9 here, equals to 0. So I have to solve this now. I can employ the cross method again. I can say 10 times 1, and also can say 1 times 9, 1 times 9, or negative 9 times 1. I can say 1 times negative 9 here. Now if I cross here, I don't get negative 1. Ne? Let me change it now. I can say 10 is to 1. Then I can say here 9 is to negative 1. If I cross here now, 10 times negative 1, negative 10, plus 1 times 9 is positive 9. It gives us negative 1, which negative 1 you see appearing here. Ne? So mean that I'm going to say that my 10x plus 9 multiplied by what? By x minus 1 equals to 0. So therefore, x equals to 1 or x equals to negative 9 over 10. But I need to find the corresponding y values. So the corresponding, I'm going to use the line again to get the corresponding y values here. I'm going to use the h of x. Hope it is simpler than the f of x. Oh no. I said I'm gonna use what? I'm going to use this h of x with these values here. Ne? So my first y value is going to be, remember our y equals to negative a half for h of x, ne? Then plus a 1 over 2. So with this one, I'm gonna say that my y equals negative 1 times 1 plus the 1 over 2. So therefore, my y equals to 0. Okay. Then now to put negative 9 over 10, I'm going to say again y equals to negative 1 over 2 times negative 9 over 10. Okay. And then plus 1 over 2. What do you get? Anybody with the calculator here? What do you get? Can compute for me 9 over 20 times 1 over 2. Which answer do you get here? I think we're going to get 19. Y equals to 19. 19 over 20, right? 19 over 20. So, yeah, that's what we have, guys. That's what we have here. So we have these values here, where the h of x meets the parabola at the coordinate, which I'm gonna call, which we call, first of all, we call it 1 is to what? 1 is to 0, and then negative 9 over 10 is to what? Is to positive 19 over 20. Yeah, that's what we have here, guys. Anybody with a question, please don't keep quiet. Ask your questions. Ask your questions if you have any. Let's move on. Next. They say here that given the graphs m of x equals to k over x plus q, the hyperbola, and px equals to mx plus c, the straight line with the b negative tends to 0 as the x-intercept of both graphs c, then c, 0 is to 3, the y-intercept of p of x, and a, the point of intersection of the two graphs c, here, okay. The asymptote of y equals to negative 1, okay, for m of x. This is hyperbola here. So y equals to positive 1, that's not negative positive 1 for the hyperbola. And so what must we do? Determine the equations of m and p. Okay, no problem. Now to get our equation for m of x, we're going to use the given information here. For example, the asymptote, let's say it was y equals to 1, so mean that our y is going to be 1. So in here, I will say m of x equals to k divided by x plus q. So because of this one here, this one y equals to 1, this one here, it means my q is 1. So my y equals to k over x plus 1. So to get my k, I use the given what point here. That's negative 3 is to 0 at point B. I'm going to say here, at negative 3 is to 0, my y becomes 0. I need to get my x equals to k divided by negative 3, then plus 1. So this k over negative 3, it can cross the equal sign to become a positive, becomes positive k over 3 equals to 1. So therefore our k equals to 1 times 3, which is going to be positive 3. That's how I find the value of k and the q, because we need the function. So our function, which is a hyperbola, is going to be our m of x equals to 3 over x plus 1. Okay, next on the q. Anybody with a question, please don't keep quiet, ask. Are we together? Are we together? Please talk to me. Okay, let us continue then. Next. After that, they also want this other straight line, actually p of x. Now p of x, we know it's passing through this what? This point A, and also passing through this q, the q, and then the B. Okay. So now, being a straight line, to get its equation, we need the gradient. We need what? We need the gradient So for P equals to mx plus c, that's what you see here, guys, this one here. We need to find m and c, then we're going to be sorted. So to get our m, I'm going to use the change in the gradient, that's y2 minus y1 over what? x2 minus x1 over x2 minus x1. Okay. All right. So now, so for this matter, I'm going to say that I'm using the coordinates of B and this one here and C. So the moment we talk about BC, okay, we say when we talk about BC, okay. So the B we have negative 3 is to 0, negative 3 is to 0, and then C we have 0 is to 3. I want my gradient, guys. So in this case my y2 is the 3 minus 0 divided by 0 minus 3. Okay, it's going to give us 3 over 3, which gives us 1. So yeah, so we have our gradient m as 1. Also we have our intercept here, which is this 3 here, guys. So our intercept c is 3. So therefore the equation of our p of x equals to m, where m is 1, x, and then plus 3. That is it here. Are we together, guys? Or somebody has a question? Are we together? Are we together? Thank you. Thank you. Let's continue. Then here, next question, they said that prove that the coordinates of A are 1 is to 4. Now, the coordinates of A, that's where the two functions meet. So, we are going to use either this one for the hyperbola or the parabola to see whether when we put in the x value, we get 4. Oh, all right. No, prove that the coordinates of A are 1 is to 4. So I must equate the two functions actually. Let's solve them simultaneously. I'm going to equate the two functions, solve them what? Simultaneously. I'm going to say that at point A, okay, at point A, my m of x equals to p of x. So I'm going to say that 3 over x plus 1 should be equal to 1x plus 3. Okay, now to solve this one here, what I can do, I can do what? I can multiply through by, I can first of all say that this I'm saying like this now, like this. I can say I'm solving now what? I'm solving like this now. I'm gonna say 3 over x plus 1. Now 1 minus is gonna be minus 2, also here minus x, okay, then minus 2 equals to 0. You see this positive 3 became negative, and then there was 1 minus 3 gives me negative 2, then the positive x becomes negative x as well here. So I'm solving this now. So I'm gonna do what here? I'm gonna multiply through by x. Okay, so here we have x multiplied by 3 over x minus x times x minus 2 multiplied by x equals 0 times x. Okay, so here I can divide by x here, left with 3, then minus x squared, and then minus 2x, okay, equals to 0. So here, if I take everything that side of the equation, I'm going to say 0 equals to x squared plus 2x, and then minus 3. So in other words, I'm now solving x squared plus 2x minus 3 equals to 0, okay? So what are the factors here, guys? Who can tell us here? What are the factors here? What are the factors here? You're going to have x plus what? X plus 3 or x plus 1, right? What are the factors here, guys? When you multiply, you get negative 3. But when you add, you get positive 2. Which factors are they going to be? Hello, hello. We can say x. Yes, what are the factors here? Tell me somebody. Hello. What are the factors here that when you multiply, you get negative 3, and when you add, you get positive 2? So I'm going to say positive 3, right? And negative 1. Is that fine with you guys? So meaning that in this particular case, either my x equals to negative 3 or x equals to positive 1 from the two factors here. Ne? After getting x as 1, I come back to find my y. Ne? So to get my y, I use I can use x plus what? X plus 3. So my y at that point where they meet is going to be given by 1 plus 3, which gives us y equals to what? Y equals to 4. And x equals to 1, which means indeed that point they talked about here in the question, which is the point A, this one here, it is 1 is to 4. It is what? 1 is to 4. So our point A is what? 1 is to 4. Okay, anybody with a question, please ask. Don't keep quiet. If you have any question, don't keep quiet, ask now. Anybody with a question, don't keep quiet. Yes, please, you have a question? It's because the 3 over x plus 1 is my hyperbola. Okay, is my what? You see from here, this one is the hyperbola here, given by what? Given by m of x equals to 3 over x plus 1 altogether. And then this is the straight line here, which was p of x. This one here, which we got here. What is it? The p of x. This one here, which we got here. This p of x, this one. It is x plus 3, and they all meet at point A. This point A is where the two functions meet. That's why I'm equating them so that I can solve simultaneously. Is it fine with you? That's why I begin by saying that at A, m equals to p. Then my m is what? 3 over x plus 1, which is this side here. Then my p is x plus 3. Then I can go ahead and solve to see what they have in common here. Is it fine with you now? Any other questions, guys, or we can proceed? Now they say here that give the equation of the other asymptote of m. Now this m has got this asymptote, which is y equals to 1. Then the other one is this one here. Let me show you. The other asymptote, by the way, an asymptote is a straight line which does not touch the function, but the function tends towards it. So this one here, in this case, as you can see, it is this y-axis here. Don't know why it doesn't work out the way you want. Okay. Sorry about that. Let me choose it again. I'm saying that an asymptote is a straight line. It is a straight line whereby the functions tend towards that line, but don't do what? But don't meet don't meet that line. Okay. So in this particular case, my asymptote is this one here. I don't know why that doesn't want to show this one here. The y-axis, ne? This one is our asymptote, ne? Because the function comes close but does not touch it. So its equation is x equals to 0. That's our other asymptote. The other one is y equals to 1. Are we together now? Can I proceed? Or somebody has a question? Please ask another question. So here we're calling it what? X equals to 0. Now they say determine the equations of the axis of symmetry of M. Now our M, which is the hyperbola, this one here, has got two lines of symmetry. The first line, it is one with a positive gradient, then the other has got a negative gradient. Let me draw them here for you guys. You can see them now properly. So my first line here, talking about, is this one here, which goes like this. It's passing through where the two asymptotes meet. This line here, this one here. I think I better put it in a green color. Ne? This one here. This line here, which I'm putting in green now. That's our first line of symmetry. Then the other line of symmetry, I'm putting it now in blue. This one here, which is in blue. Okay, it's supposed to be a solid line. Eh? Okay, let me do it again. It must be a solid line. This one here. Yeah, this one in the blue, guys. This one is our other line of symmetry. So a line of symmetry is a line that divides the given function into two equal portions. Now these hyperbolas, you can see this part here and this part here, they are symmetrical along this line of symmetry. So now to find these equations, this is what we do, guys. Just listen to me. Now the one which is in the blue has got a negative gradient, actually which is -1 gradient. So to find its equation, this is what we do. This is what we do. We say that our y equals to -1. Okay. Then what we do, we put the x which is down here, and then we say plus the asymptote which was +1. So this equation is our line of symmetry, which has got a negative gradient. Don't forget the formula. It says that our y equals to x plus what? X plus p. But if it's a negative gradient, must put a -1 here, must be -1x. Then the one with the positive, which you see here in green, will be given by the formula, which says y equals to +1x plus p, but p is what? Our p is this 1 here, so +1. So this is what they want here. They want this equation here and this equation here as well, because they are the lines of symmetry, one with a positive in green, positive asymptote, positive gradient, the other in blue with a negative gradient. Anybody with a question, or we are together? Please ask, don't keep quiet. Should we proceed? Okay, thank you. Then next question here, let's check it out. What talks? Let me send a screenshot, by the way. Did I send it already? Okay. I think I just sent you one. Okay. Yeah. Okay. Now here they said that now apart from that, because we're done with the lines of symmetry, né? This one here, that's axis of symmetry. We are done with this now. We're done with this one now. Now here they say determine the equation of the straight line q of x, which is part of p of x and passes through the point -1 is to 0. I repeat, determine, determine the equation of the straight line q of x, which is parallel to p of x and passes through the point -1 is to 0. So guys, if the lines are going to be parallel, what is common with them? Hello? What's common with lines which are parallel? Any ideas? What is equal? What is equal? Yes, talk to us. What is equal? Guys, if the lines are parallel, they have equal gradients. They have what? They have equal gradients. Ne? What about if they're perpendicular? What do you say about the gradients? We said what? We said that if they're perpendicular, and then you multiply, you must get what? You must get -1. Ne? So now this question says that they have a line which is parallel to line P of x. Ne? This one in the black was our P of x. Ne? But it's passing through which point? They said passing through. Let me check it here. Just check it here. They're saying, and passing through -1 is to 0. And it's parallel. Ne? So actually it could be this one here. Let's find out. This one here. This one. So now this line and this other one, they should have the same gradient, ne? As long as they say they are parallel. Ne? So from the P of x, our M1, okay, equals to, from here, equals to 1. We have it here, ne? Equals to 1. So this line, this is the line I'm going to call it line 1. Ne? So this line 2 has got gradient M2. So our M2 also equals to 1 because must be the same as that of M1 since they are parallel, okay? But I said passing through the point -1 is to 0, ne? Passing here now. Now if I know this point, -1 is to 0, then I'm gonna use y equals to mx plus c, y equals to mx plus c to find that line. So y is 0, the m we go to 1, x we have -1, then plus c. So it's going to be our c equals to +1, and hence it's going to be given by what? Y equals to what was our m? Equals to 1x equals to x, then plus 1. That's what we have here. Actually, the same as the green one here. That's our line they're talking about here. Okay, anybody with a question, or we are together? Are we together, guys? Or you have a question? We can proceed. Let's proceed now. They say that then, what do you notice about the line in question E? You see, now the line in question E is the same as what? The line of symmetry with a positive gradient. That's what we notice here. I repeat, the line calculated above is the same as what? The line of symmetry with a positive gradient. Next question. They say that determine the points where q of x and m of x intersect. Now this line we just got now is q of x and then m of x. Ne? So in other words, I want where this q meets m of x. Ne? Now our m of x was what? Don't forget the equation here. Was the hyperbola. This one here, which gave us what? Which gave us 3 over x plus what? Plus 1. Okay. Which gave us what? 3 over x plus 1. So I'm going to equate the two now. I'm going to say that q of x equals to m of x. Ne? Are together? But I know my q of x now. It is what? It is this line here. We just got what? We just got x plus 1, okay? I'm going to say this is x plus 1. That's my q of x, ne? Q of x equals to what? X plus 1. And then our m of x, already we got it, ne? We say it is 3 over x. 3 over x plus what? Plus 1. Okay. 3 over x plus 1. So now, we're solving these two equations here. I'm going to equate them. I'm going to equate them now. So to equate these two equations, I'm going to have x plus 1 equals to 3 over x plus 1. Now to solve here, I can use okay, I have to do what? Now this x is going to cancel out with this x here. Well, 1 and 1 are going to cancel. So I have x equals to 3 over x. Ne? If I cross multiply here, I'm going to get x squared equals to 3. Okay. So to get my answer, I'm going to say it's going to be now x square root here. So x equals to plus or minus what? Root of 3. So that's where they intersect. I have my x already. So to get my y, it's going to be y equals to x, which is root 3, plus 1. So they intersect at what point? At the point which is, that's root 3, okay, is to 1 plus root 3. This is where the two functions intersect. Hello, are we together? This is where the two functions do what? Intersect. Anybody with a question, or we are together? Yes, please ask the question. Y is what? The coordinate of y? Root 3 plus 1. Yes, it's because my line, which is the one which I just talked about, is given by this equation here. This equation here. This equation here, isn't it? This one here. Okay. You see this equation, right? From this equation, y equals to x plus 1. But what's our x? It's root 3, isn't it? Then plus 1. That's why I'm putting it here. Are you answered now? Thank you. Guys, we can stop here. Thank you so much for watching. See you again tomorrow. Or see you for physics, ne? Thank you. Bye-bye.